mass, moment of mass, center of mass, centroid, moment of initial. So it is exactly same concept for the double integral. And now for triple integral, we have three integral. Okay, and the solidity, and this is the density. Okay, so MYZ will be okay. So MYZ will be triple integral Gx delta the density dV. Mxz will be y delta xyz, and mxz and mxy will be z delta x. Okay, so you can see here if there's nothing, so the alpha missing is x, so you put x in. The missing alphabet will be y, put y here. And the alphabet missing for this will be z. Okay, so this is for moment and this is for mass. So for center of mass, we have myz, which is x, the triple integral x, and then mxz, which is triple integral y delta x, delta times dv, and mxy over m, which is triple integral z density times dv over m. So if the density is constant, this point we call centroid. It's same as double integral. Okay. Suppose a solid occupies a region R, that density of each point in R is given by delta, the moment of the inertia. Now the moment of inertia. The moment of inertia will be triple integral G. For x is y squared plus z squared. For y, x squared plus z squared. For z, x squared plus y squared. Okay. Here we see some example. This is cylinder and this is parabola. So we call paraboloid cylinder. Find the centroid of the solid density delta bounded below by the below by. So bounded below by means above the. Okay. So bounded below by means above the. Okay. The disk in the Z0 and above by. So means below the. Okay. Z equals to 4 minus x squared plus y squared. So first you have to sketch whatever given here. Okay. Pay attention for the bounded below by and above by. Sketch the circle region in S in double integral dA. Write the formula of the centroid. Find the limit dA, limit of the integral. Okay, centroid. So what is the formula for centroid? This is moment of inertia. Centroid is this. Okay, density is constant. Constant density you can let is 1. So now your calculation will become a little bit easier because we can omit this. But you have to find MYZ, MXZ, MXY, everything. Okay, so this is your sketching part. This is 4 minus x squared minus y squared. I assume that you already know this, and the bottom part will be this. So by symmetry, x bar equals y bar equals 0. We only need to find z bar. Okay, for this case, because of the symmetry, left and right are the same, so the circle are the same. So you don't need to find x bar and y bar. So x bar will be 0, y bar will be 0. You just need to find mxy. Okay? If you have to find all, become more tedious work. Okay, so they have made simpler to you that x bar and y bar will be equal to 0. If you want to find also can, you get 0. So we just focus on mxy. So mxy formula will be triple integral gz, because z is missing here. Density function will be 1 dv. Okay. Okay. Okay, so we see the solution. So I have given you a solution. Okay, this is solution. So make sure you already know how to draw the traces and everything. So x by y by is a symmetry, it will be 0, z will be fx over m, and this is just nothing. So this is the solution. So we have, okay, because we have paraboloid and circle, we can use cylindrical coordinate. You can use spherical coordinate also, but it will become more tedious. So that's why I have to use cylindrical coordinate, because the solid involve the circular base. So this is the technique. Okay. So you have 4 minus r squared, and then the circle is 0 to 2, and then the angle will be 0 to 2 pi. Okay. So the bottom one will be 0, the above one will be 4 minus r squared. Okay. And then the other thing is just a calculations. Okay. Okay, you can let one, or you can put outside the density, and then you have to find the m. You can use the same limit, and then you just divide. You will get 4 over 3. So 0, 0, 4 over 3. Do you have any question for this? You have to try to do the integration. Remember, do inside one first. Then that solution integrate respect to dr, and that solution respect to d theta. Okay. Okay. Next example. We have plane and density 2x. Okay. Now it will be more harder. So center of mass will be okay. So we have to find everything, which is the plane. Then we have to use type 1, type 2 also. So m, y, z, okay, which means x, and this thing can be anything, del z, del y, del x, or dx, dy, del, it's okay. Okay, because it's up to you how you see the graph, you see the surface. So this is when z0, y0, and x0. Okay, you can find for myz. So myz. Okay, which is x times the density, which is 2x. Okay, then you have to find mxz. You just use the same limit. Okay, you can see here, you can see the same. The same limit for y times delta x, and same limit for mxy. The m will be fixed. Okay, and then you just divide. Okay, so ice cream cone. Okay, about the ice cream cone, you have p on p. We have ice cream cone g cut from the solid rho equals to 1, which means, so rho is what? What is rho? So rho is actually square root x squared plus y squared plus z squared, right? Is that one? Then what else you have? You have by the cone phi equals to pi over 3 about z axis. Okay. Okay. So they give you phi equals to pi over 3 and rho equals to 1. And this is the r. Okay. Remember, the rho should be from the 0 to the sphere. Angle should be from z axis. and clockwise. Okay. So this is your cone, ice cream cone. This is ice cream. So your theta will be 0 to 2 pi. Your phi already given from 0 to pi over 3. And your rho should be start from 0 to 1. Okay, this is all given by the question. So you just have to find the moment of the inertia, okay, about z-axis. So moment of inertia about the z-axis is this. Okay, so x squared plus y squared delta xy. So they ask you to take 1. So you just substitute it 1. And x squared y squared is, remember your x squared will be rho sine phi cos theta, and your y rho sine phi sine theta. Okay, and dv will be rho squared sine phi d rho d phi d theta. Okay, and then you substitute everything, then you get the answer. Can just a formula. So you have to practice how you to integrate everything. How to integrate tangent, how to integrate hyperbolic tangent, and everything else. Okay, can. Any question? Okay.
Okay, Doctor.
Okay, let me check. Okay, next week will be the mid-sem break. So no class next week, right? No class here. So yesterday and today we have class. So our class will be start on Sunday, is it? Sunday also we have don't have class. This is Hari Raya, Idul Fitri. So maybe Monday we have class. Okay, so 1, 2. So your Raya will be 1, 2, 3, 4. We see how we're going to continue here or not. Okay, maybe if you don't want, we can continue here. Maybe you want to take leave. Okay. So I stop here. So after mid-sem break will be the vector value function. Okay, is it okay?
Okay, Doctor.
So I stop here. So happy holiday and selamat Hari Raya.
Thank you very much, Doctor. Selamat Raya.
Selamat Hari Raya, Doctor. Thank you, Doctor.
Okay.
Thank you, sir.
Thank you, Doctor.